it sounds awful, but it's really not so bad. So I'm going to first put it in context of 4th grade again. Okay, it's good for us to remember the things we did once before in elementary school. So I'm going to talk about something called the division algorithm. And before I tell you what the division algorithm is or what the division algorithm says, I'm just going to do a division problem. So I'm going to do 6,543 divided by 12. Okay, so remember, we would have started yesterday with that very first number in the dividend, 6,543, and we would have thought 6 divided by 12 doesn't work. So 65 divided by 12, 5.
Yo, you know what's weird? I just realized, like that, like, you know how like 6 goes into 12, like you can't do it, but 12 divided by 6 is 0.5, so you put it point, and then you put like the 5, and you put the 5 right there.
Does that work for everything?
Okay, 54 divided by 12, 4. And 63 divided by 12. Back at 5. So we got 60. We got 3. Okay. So now I'm going to go through and I'm going to label the parts of this. So we said yesterday, right, this was the dividend, the thing you're dividing. Okay, this is the divisor. And this is your quotient. And then this is your remainder. So every division problem really has 4 parts, okay? The division algorithm is this idea that, and you can ignore the bottom parts here, the dividend is equal to the divisor times the quotient plus the remainder. I mean, that's what's happening in these numbers. So I'm going to put them in the numbers. Do you agree that, like, when you divide this and you get all this stuff, it's saying 6,543 is equal to 12 times 543. But I had these 3 extra ones that I couldn't divide, so what do I do with that remainder? Just add it. Plus 3. 545, thank you. A kid move right there and right on top of it. Okay, do you agree that that's what that says?
Yes.
Okay, that's what the division algorithm is. The division algorithm sometimes sounds scary because it's called an algorithm, but an algorithm is just a list of steps. And these are just the steps of long division, what they mean. Now, I do have some extra words down here at the bottom, such that the divisor is not equal to 0, because what do you know about dividing by 0? Error, no good, not possible, never done it, never going to, not going to happen. Cannot divide by 0, right? And on a side note, I think we mentioned this yesterday, so I think we would all just agree to this, that your remainder is always a positive number, so it's bigger than 0. It could be equal to 0, right? You can have 0 remainder. But at the same time, your remainder has to be less than your divisor. Like if I had a remainder of 13, that could mean that I could have put 12 in one more time and had a remainder of 1. So I think we would all agree to those rules as well, that the divisor can't be equal to 0 and the remainder can't be more than the divisor. Okay, so not so scary when it's in number form, right? Or in context of another problem? Okay, so now I'm going to write the division algorithm for polynomials, which polynomials are those things with many terms, right? And we often represent them with function notation. What does function notation look like? F of x, g of x, h of x. So I'm going to go ahead and write out a division algorithm for polynomials, and it looks like this. F of x equals d of x times q of x plus r of x. Now, I'm choosing my letters to represent different things, right? D of x is going to be my divisor. Q of x is going to be my quotient polynomial. R of x is going to be my remainder. And then f of x, that's just like my function or my dividend, the thing I'm dividing. So this says the same thing that was on the screen before. Spell it right first. This says the dividend equals the divisor times the quotient plus the remainder. Okay, now the rest of what I do on this slide is just to kind of introduce how the remainder theorem works. Okay, so remember that day we did the quadratic formula with A's, B's, and C's. So I'm not going to say like, you have to know this, you'll have to be able to reproduce this, but it's nice for us to see, especially since we're honor students. So now you see where the remainder theorem comes from. But for some of us, maybe it won't be crystal clear right away. And I'm going to say, that's okay. Just let it sit with you, maybe go back and look at it. We can talk about it another day, but at least like try to stay on the train of what we talk about in terms of how the remainder theorem comes to be or what we're doing. But don't worry if this part is a little bit fuzzy. That's okay. Okay, so let's suppose that my divisor polynomial is a binomial divisor, which means two terms, and it's linear, x minus k. Okay, so this is a linear divisor. If d of x is equal to x minus k, in the division algorithm, I can replace d of x with x minus k. Okay, so that's what I'm doing right there. So I'm going to say, that means that f of x equals, I'm going to rearrange my stuff here, q of x times x minus k, multiplication is commutative, so I could do that, plus r of k. Oops, r of x. So all I'm saying is let the divisor be x minus k. Okay. Now, think about what the division algorithm meant back in that long division problem we were doing. You're taking your dividend and you're dividing it by the divisor. So when we think about setting up that division problem, that's like f of x divided by d of x. Do you agree with that? Okay, so if my d of x is x minus k, the linear factor, if I were going to divide that, I could divide that with polynomial long division, or I could divide it with now synthetic division. What would I put outside of synthetic division?
Okay.
Oh, put out a k, right? Okay. So if you're dividing by x minus k, what's my x? If you're dividing by x minus k, then what you're saying is x equals k. So we would divide by the 0 of that linear factor. We would set it equal to 0. We would add k to both sides. So now I have a new statement here. It says substitute k for x. What I'm saying is let x equal k then, because that's what we say when we do synthetic division. Okay, so we're going to let x equal k. And so everywhere in these function notations where I see x, I'm going to write k. What happens to k minus k. It actually turns to 0, okay? And then what happens to q of k times 0? It's just 0. So what I really end up with is f of k equals
Your remainder.
your remainder. If you're dividing by x minus k. And then this is the remainder theorem. Grace.
How did you get rid of the quotient k?
It's getting multiplied by 0.
Oh, it doesn't have a plus separated.
So it is 0. Okay? So, that's kind of like the thing that's happening. We're thinking about it in terms of the division algorithm, in terms of what we're dividing by that linear factor. So we would be letting x equal k, and when we let x equal k, we then end up with just the remainder. So here is your remainder theorem. Make sure you write this down. If a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. We're going to be putting in different things for k. It's just in the theorem. That's how the theorem states it. So it could be any letter. However, we're going to be putting in numbers, not letters. Okay, so if the polynomial f of x is divided by x minus k, then the remainder is r equals f of k. Okay, so mathematicians, we always kind of word our theorems all mathy-like, right? The way you like them. And they don't always make sense when you read them over later all by yourself. So I'm going to write in my own words basically what this remainder theorem is telling me. The remainder theorem is, notice I kind of got rid of my r of k because we're going to be working with numbers. So then it's just going to come out to be a number. It's going to be a constant. Okay, so it's simply r equals f of k. And what this says is the remainder, r, is the value of the function at x equals k. So in my own words, what do I read into when I read the remainder theorem? It tells me that the remainder is the value of my function when x equals k. So basically it's finding y. The value of my function is a y. Which makes sense because we're saying the remainder is equal to some function notation, and function notation is really just a fancy way to write y. This f of k means y when x equals k. So the remainder is y when x equals k. That's what the remainder theorem says. Okay? So what does that mean? Synthetic division can be used to evaluate polynomials. Yay! What did we decide the word synthetic meant yesterday?
Fake.
Fake. So we said, oh, okay, we're going to do fake division now. It's not really long division because we don't really have to think about dividing. We just do this little mantra, add down and multiply, right? So it's not really dividing, but somehow it divides. Okay? And I didn't prove that. But somehow it divides. So not only can we do synthetic division, but we can also do something that sometimes is referred to as synthetic substitution. So synthetic substitution would mean fake substitution, right? We're not really substituting in for x and working it all out, but somehow when we do it based on the remainder theorem, it actually works. We get our y value. Okay, so we're going to be using synthetic to evaluate polynomials, which is find y values. Okay, We'll do that on the first example, and that will maybe be a little bit more clear when we do the example. This one I don't think you really have to write down because I think it's basically what the remainder theorem says. I made a note to myself to just erase that second bullet point, but I'll just repeat it one more time because it never hurts to hear it again. To evaluate f of x when x equals k, to find f of k, then divide the polynomial by that x minus k. So we're going to be doing synthetic, and the remainder will be f of k. So the remainder will be the y value. The next one I would probably write down in my notes, which is this red one, and it's a spoiler, so I'm sorry. Couldn't help it. Okay, spoiler. My spoiler is, when your f of k is equal to 0, which basically means your remainder was equal to 0, right? Because your remainder is f of k. When your remainder is equal to 0, that means that x minus k was actually a factor of your polynomial. And we know from quadratics, if it's a factor, then we could set our factor equal to 0, and that would be an x-intercept on our graph. So that little remainder theorem, r equals f of k, it seems so small, it's so big for us. When we return after your 3-day weekend, the last half of the chapter is spent finding ways to get the x-intercepts for our graphs. And synthetic division is one of those ways. When we want to have x-intercepts, we need our synthetic division to come out to 0. That's why I put smiley faces in all my zeros, because they make us happy. Okay. So remember, this f of k is really saying your remainder equals 0. If your remainder equals 0, it is a factor, it is an x-intercept. Think about that. Give me factors of 15.
3 and 5.
Why are 3 and 5 factors of 15?
3 times 5 equals 15.
Well, they multiply to make 15, but so does 2 and 7.5. Whole integers, or when you divide 15 by 3 or divide 15 by 5, what's true about your remainder?
0.
0. So 0 remainders means things are factors. When you divide 15 by 2, you get a remainder of 1. That's not a factor.
I was going to be like, no, you get something like 5.
Well, you can get an answer, but it's not a factor. So the same is true for polynomials. All those polynomials we were working with when we came up with funny remainders, those are not factors, those are not zeros of the polynomial. It does not cross the x-axis at that moment. If we get 0, it does. So that'll come later, but that's a good thing for us to at least think about right now. Okay, now let's do an example and try and make sense of all this. I would put this one example into your notebook. Okay, so it says evaluate this polynomial f of x when x equals -2. What's the old way of doing that? Plugging in -2. Okay, so I'm going to illustrate the old way first. And this is not how I want you to practice it on your homework tonight. So if I wanted to do f of -2, I would do 4 times -2 cubed minus 2 times -2 squared minus 5 times -2 plus 11. That's 4 times -8 minus 2 times 4 plus 10 plus 11. So that's -32 minus 8 plus 21. So what is that? -40 plus 21, -19? But that can be kind of hard to do accurately. Like you guys did that on your concept check when you were trying to fill in the table. And you do it a lot and you kind of get lost, or you need your calculator and you got to put the parentheses, and that's a lot of typing, right? Okay. What we just talked about said, if we divide this polynomial, and what's the highest exponent in this polynomial? X cubed. So we're going to do x cubed, x squared, x and a number. And I'll drop in my coefficients. 4, -2, -5, 11. When it says when x equals -2, what am I going to put on the outside of my synthetic?
2.
What did it look like yesterday?
Oh, it was where it was x minus 2. But
It looked like x minus 2 or x plus 2. And how did you figure out what to put on the outside of the synthetic box? You found the 0. You set it equal to 0 and moved it to the other side. So you got something like x equals -2. And then you put it on the other side. So if it says x equals -2, what are we going to put on the outside of our synthetic? We're going to put -2. When do you change what you put on the outside of synthetic? When it looks like a factor. When it looks like x minus k. Whether that be x plus 2 or x minus 2. So what this means is I must be dividing this. I'm taking f of x and I'm dividing it by x plus 2. But if I were to set that equal to 0, that gives me x equals -2. So that's the number I put on the outside.
So I noticed we have the -2 on the outside. Does it always have to be in that like whole number integer format? Can it be like a binomial, or does it always
It
have
can
to
be a binomial, which is why you have to know long division, but it could be a fraction or a decimal.
Okay.
Since x is equal to -2 and there's an x being clean, can you divide them all by -2?
Because the constant doesn't have a -2. Okay, so now we just run through synthetic. Add down to get 4, multiply, -8, add down to get -10, multiply to get 20, add down to get 15, multiply to get Same answer? This is my remainder, right? So this was now x squared, x, and a number, and then my remainder. But for the purposes of the remainder theorem, if I'm evaluating the polynomial, f of k is equal to r. So what we're saying is f of -2 equals -19. Is that true? Yeah. And if you wanted to graph a polynomial, then you know that -2, -19 is a point on your graph, right? It could go left 2 and down to -19. Okay, it worked. So this is what you want to practice on your homework tonight. If you want to double check in your calculator, you can do the direct substitution, but I want you to do the fake substitution, synthetic substitution over here.
So the answer would be f of -2
Yep. F of -2 equals -19. Really, -19 is your answer. You've evaluated the polynomial, but I would suggest writing it as an ordered, as the function notation. Then you make sense of the ordered pair, and it becomes useful. Okay. Other questions that you want to ask me about that? Okay. Now we have one last example that I want to look at. I'm going to change. I wrote box and tank, so I'm going to change it to box. Where's this? That's not true. Okay. Sorry, that's me typing and doing weird things. Okay. The volume in cubic feet of a box is modeled by this polynomial. Do you remember that day when we wrote a polynomial for volume? Like I said, okay, the height of the box, the width is 3 more than the height, and the length is 1 less than twice the height. We wrote out the 3, and then we multiplied them because volume is what? Length times width times height for a box. Okay, so volume equals length times width times height. And we know the volume is multiplied by this polynomial, and then the length and the width of the box are x minus 2 and x plus 5. So what's the height of the box? Oh, okay, so Lilith is saying x minus 2 times x plus 5 times, can I just say h? Equals volume, that other thing, x cubed plus 2x squared minus 13x plus 10. And I wouldn't necessarily set this up every time. It's like once you figure it out, you kind of know what to do. Okay, but for our purposes, this is the first go around. We'll go ahead and set it up. How would you solve for height then?
You would multiply x minus 2 and x plus 5. You would FOIL it out, and then you would divide that from the
Okay, you could do it that way. So if you multiply x minus 2 times x plus 5, what are you going to get? Something that is long. It's going to be a trinomial. It's going to be a quadratic, right? And if you then divide both sides by that quadratic, what type of division will you have to use?
Is it long?
You'll have to use long division because we can't do synthetic with an x squared, right? Okay, so certainly, Grace, that is an option. But I'm going to teach you how to do it with synthetic so that we kind of have this skill in our toolbox. But do you agree with Grace that, like, basically we need to divide off those two things that are being multiplied by h? Okay? So I'm just going to make a big division here and say, really what I want to do is divide everything by x minus 2 and x plus 5. Okay. Now, on this side, it will just cancel out. On this side, I'll have to take that x cubed plus 2x squared minus 13x plus 10 and divide it by both of those. Okay, now here's the really cool thing about synthetic. You can build on synthetic. So you can do synthetic once to divide, and then you can build right off of it and divide again. So I'm going to set up my division. What's my highest exponent? X cubed, x squared, x in a number. I'm going to drop in the coefficients, 1, 2, negative 13, 10. And I'm going to divide by one of the dimensions of the box that I know. So I'm going to divide by x minus 2. I'll put a 2 on the outside. This is where I have to change the sign because it looks like a linear factor. Now, if it's a factor, I would expect what at the very end of this problem?
No remainder.
No remainder. My remainder will equal 0. Okay, so let's hope. Fingers crossed. 1, 2, 4, 8, negative 5, negative 10.
Smiley face.
Cool. It was a factor, right? Okay, it was one of the dimensions of the box. Now, I'm left now with this x squared, x, and a number, and it divided nicely. So I've divided by x minus 2. Now I can just build right underneath it and divide by x plus 5. So what am I going to put on the outside? Negative 5. Run through my synthetic. 1, negative 5, negative 1. So this is now, this was x squared, so this is x, and this is a number. So what's your missing dimension? Or your height?
1. It wouldn't be negative 1 because that would be negative 1 height. Doesn't make sense.
Well, what's left over? X minus 1. We don't know the height until we know what x is for all of those, right? We don't know the length or the width until we know the x value. So your height is x minus 1. Now, it wouldn't matter if you did negative 5 first and then 2, you would still come up with x minus 1. So order of division doesn't matter there when you build off of synthetic. It should still work either way. But that avoids us having to do long division, which is what Grace recommended, which is totally allowable. So if you want to do it that way or try it that way on a homework problem that you see like that, you're free to do that. Okay, but I like to practice that synthetic. Does anybody have any questions for me about this? Yes, Grace.
So, how did you find so I know like x equals -1, so you take whatever the last number is. Is that?
Well, no. So the thing that is left over, remember, we're just dividing and we're getting these quotients. So my quotient is 1x minus 1. That doesn't mean that x is equal to 1 necessarily. Okay, that would be a 0 of the polynomial, but that doesn't tell me what my height is. All I know is that my height is x minus 1, just like all I know is that my length and my width are x minus 2 and x plus 5. Until I know an actual number somewhere, I don't know what x is.
So you picked that number on the end because it's x.
I picked the number on the end. This one?
Because it's your x.
Well, it's just what's left over. I have whatever I divided once, I got a quadratic. I divided by the second one, and I got the linear. And that's what's left over. That has to be the other thing that I'm multiplying. It's like if you take 30 divided by 2 divided by 3. Well, 30 divided by 2 is 15. 15 divided by 3 is 5. So then it means 2 times 3 times 5 is actually 30. So this means that x minus 2 times x plus 5 times x minus 1 gives me the x cubed plus 2x squared minus 13x plus 10. So that's the other factor that gives us that polynomial. Now you have a homework assignment for this evening. Okay, it's what, 6 problems? But good thinking problems, maybe. So make sure that you do them. You are capable, you are smart, you are intelligent. Say all those things to yourself. You are learning a lot here.